Hello, maurieos! Land Survey 1, Level Reductions, Height of Collimation Method, Question 5, 2013, Semester 2. Hello. Well, it's the night before the exam, and a student has emailed me asking some questions about this question. So, I've decided to quickly, hopefully do a video, and hopefully it's going to occur in time. So, yes, we'll have to see how that all pans out. So, I've set up the. I'm trying to set up the situation here so that we can get it all going. So let's. I've got it all there on the big screen. So let's transition to the big screen, and here it is. So this is the model answers from 2013. Semester 2, the June NZTE examination. Okay, so it's worth 22 marks. Well, level reductions is anyway. So this height of collimation method, it's not a method that I'm a big fan of, so I don't particularly teach a lot of it, but I do go through the exam questions in that, and hopefully if it does come up, my students have got a fair chance of answering it. So it actually refers to Appendix A, where you have to reduce a series of levels. So we'll go to Appendix A, which is here, and we'll just make that even bigger again. So this is Appendix A, and the red is what's obviously got to be done. So what the height plane of collimation situation is, and I'm just going to at this point try and set up my calculator so that I can get that up on the screen, because that may be of some help, and it's not appearing easily as it usually does. So I've got it here somewhere. Oh, here it is. Here's my calculator here. So we'll just get that up and running. It's on my second screen at the moment, coming across, and we'll put it up in there, my little calculator. Okay, so what the height plane of collimation does is it essentially finds out the RL, if you like, of the level. So this is the starting level here, 69.505. And you just add to that the backside, and that will give you this height of collimation here. So that's plus 2.125 equals, and we'll just push that there, and that's 71.630, which we've got there. So let's just get into here. Shift mode 63 equals. Okay, and yeah, 671.630. So that now becomes the height plane of collimation, and everything references to that 71.630. So I'm just going to store that in A. Okay, and that there should be stored in A. So now we go back, and if we want to find the RL of the next one, the intermediate there, we just subtract that, so that just becomes minus 2.936 equals, and that gives you the 68,694. And similarly, the 2.810 comes off the 71630. So we just go recall A minus 2.810 equals, and that's 68820. And similarly at this one here, where we've got a foresight, so it's just recall A minus 2.69 equals, and that's 68940 of that point there. Now when it comes to the next setup, and there's another setup here because there's another backsite, then the backsite gets added to that value, 69940. So we go plus 1.584 equals, and that gives us 70.524. So that's the new height of collimation, or height plane of collimation. So we store that in A. Okay, and then we start taking away from that. So that's 2.297 is taken away, 202, 2.620, and the 1.044. So I'll just do that one. Minus 1.044 equals, and that'll give us 69.480, like so. And then we create a new height plane of collimation, which is 71232. So that's 69480 plus 1.752. So plus 1.752 equals, and that gives us that whole height plane of collimation, 71232. And then we subtract from that the 1.896. And that gives us there 69336. Okay, and that's to the valve. Now, just looking at this traverse, it starts there, and then it takes some shots on a manhole here, and then it's along the line of the manhole. So this is at chainage 0, 20, 43, 54, 60, and so on through to 86.6. And then it closes off onto the manhole lid. There's a 6mm misclose there, which is just been stuck in there. So it hasn't actually been adjusted out as such. It's just been deemed to be acceptable and deemed as being acceptable, and then around to there. So there's a 6mm misclose. It hasn't, it's insignificant really in the scheme of things, hasn't been closed out. In terms of checks, here we've added the back sights, added the foresights, and the difference between the back sights and the foresights should be the same. So that's 5.461 minus 5.630, which should be 0.169. And similarly here, 69,505 minus 69,336, 0.169. So that's the checks that have done here. That have been done here. In classical height plane of collimation with a full correction in here, there are other calculations that can be done to check the arithmetic, but perhaps the best thing here is just the backsights and foresights. The difference between the backsights and foresights should be equal to the difference between the start level and the finish level, and that's probably more than enough here. All right, so let's just, that's that done there. Let's just have a little note here. So we've got a 6mm misclose there. We've got 1, 2, 3 back sights and 3 foresights. So that tells us there's been 3 setups. 3 back sights, 3 foresights, 3 setups. The number of intermediate shots is irrelevant. Okay, so let's just go back, just reduce this down and go back to the question now. So that's pretty much the sheet all filled out. Be very careful with this type of question because if you make a mistake in the sheet, can transfer through all the things. So what is the leveling misclose? Is it within tolerance? Given the tolerance of the level run is plus or minus 5mm times the square root of the number of setups. Well, as we said, the square root, the number of setups is 3, and the misclose is 6mm. Therefore, the tolerance is, they say 8.7. Let's just check that out. So it's 5 times square root 3 equals, and that's 8.660, 8.7mm as indicated there. So that's miscloses there, so 8.7, so it's within tolerance. We've got a 6mm misclose. The tolerance is 7mm. Okay, so next step, what percentage of grade of the existing pipeline between manholes 26 and 27 take depths from manhole lid to invert level into account at each end? What is the percentage grade? So the best thing to do here is to try and draw a diagram and try and keep the diagram real. So I must admit I've had 3 goes myself to get this particular diagram right. So be very careful from the start. So first of all, so you need to go back to the here, and what you find is you've got manhole 26. Unfortunately, that should be manhole 27. So you've got manhole 26 has got a lid level of 68.694, and we're getting that from here. 68.694. Quite sure. I'll just check something out here. Oh yeah. And here we've got the inverts, a depth to invert of 1.06 and 2.56. More about that in due course. So 68.694 is the ground level, and the ground level at the second one is 69.480. So it's sort of 69. Oh, 69.480, which is here, 69.480, which is, there's a slight rise up to there, 68.694, 69.480 is the rise up to there. And you'll notice that the depth to invert is 1.06. So these are manholes. They're sort of around about a 1200mm chamber. So this is the lid in here, or the cover. And then down to the invert level of the pipe. Now the invert level of the pipe is the bottom of the pipe. It's the bit of the pipe that's always where the water flows, minimal flow. The invert will always be wet. So it's the bottom of the pipe, and the top of the pipe is called the soffit. The diameter of the pipe is as shown here. There's 2 types of diameter. There's an ID, which is an inside diameter, and an OD, which is an outside diameter. In this particular case, they've used nominal pipe diameters of 375 and 225. These are typically the internal diameters, but they have not seemed to have taken into account the the thickness of the pipe in this particular question. So we're just treating it actually in this instance as the outside diameter, and that is possibly incorrect, or perhaps I'm just getting too technical. But so we'll just treat the pipe as having no thickness in this case. All right. So and we've got some RL of there is 68694. Now that's come from here, the manhole lid, and 69480. Again, the manhole lid has come from here. So let's just go back to the question again, which is here, and the model answer as it turns out. So we want to work out the grade, percentage grade there, and so we've first of all we've got an RL there, 68694. We subtract the depth to invert, and that's going to give us an RL at the invert of 67634. And so we draw this up. Notice that's 1.06. This is 2.56. So this is roughly 2 times that one. So when you draw that up, you'll see although the ground is going up, the pipe is going down. Okay, so then we can come up here and find the invert level of the pipe here, which is 69480 minus the depth to invert, 2.56, gives us 66920, and that's our invert level there. So our percentage grade is rise over run times 100%. So that's going to be 66.920 here, minus 67,634 here, divided by 86.6, which is the distance given to us between the 2 points, 86.6. So we multiply that all out, and so let's go 66. I'd like to put it in bracket, 66.920 minus 67,634, 67.634, close the brackets, times, divide 86.6. I'm going to go equals here, and you'll see that you get negative 0.008. For grades, you want that more than 3 decimal places, so shift mode fix 6. 6. And hit that there. So we get 0 minus 0.008245. I've got 2448, so I've gone to 7 decimal places. So I like to keep as many decimal places as I can. Percentage. So that's the answer to C, the grade, which you can see there. They've got it slightly wrong there, but the intention is good in the model answer. All right, so now let's go to D. How deep will the new manhole be? So there's a new manhole to be, and they've put a peg in there, and it's to be midway between these two, halfway between 86.6 and 60 is 43.3. So we want to know what the invert level of that manhole is going to be in the first instance. How deep will the new manhole be, taken from the top of this peg that they've put in here, and we've got that off the leveling sheet of 68.940. So the invert level here, obviously we know the grade now. Here's the grade between the two pipes. So the invert level at 43.3 will be 67,634, which is the RL here, minus 0.8244, the grade, percentage grade over 100, times 43.3, which is the distance that we're travelling. And if we work all that out, we get 67.9 67.277. 67.277. And that's going to be the invert level at that point, 67.277 at this point here, at the midpoint, right here where the hand is. Now, but the question says how deep? Okay, so we need to take the depth. So the peg RL at 43.3 is 68.940, and the depth of the new manhole will be 68.940 minus 67.277, the invert level, which is 1.663. I'm reliably told 1.663. All right, now E. Does the existing pipeline have an excess of 600 millimeters cover at the road at 54 meters along the route? So tried to draw a little road in here, and it's 54 meters along from there to the road. So we need to work out the invert of the pipe here, and the invert of the pipe, and then the top of the pipe. So we can only really work out the invert, and then we we're going to add the 375, because this pipe here, the existing pipe is 0.375, and then they've found another pipe over here of a 225. These are nominal dimensions, so a 225 is a 150 plus 2, 3 inches, 6. It's around about a 9-inch pipe, I think, in old money. A 9-inch pipe. A 375 is a 300. A 300 is a foot, is 12 inches. That's about a 15-inch pipe, in old imperial money. Okay, all right. So, yes, so we're going to work out, first of all, the invert level there. So at 54, same calculation as here, 67,634, this invert level here, minus the grade times the distance, 54, and that gives us 67,188. Now that's the invert level. The top of the pipe is 67,188 plus 0.375, which gives us 67.563. 67.563 is the top of this pipe here. And then we know the road level is 68.227. 68.227 there. We subtract the 2 and we get 0.664 meters. 0.664 coverage. Therefore the cover is 0.664, so that's the distance between the top of this pipe and here. So you want pipes usually a minimum of 600 below the ground, particularly if it's going under a road or anything like that. If it's less than that, the constant trafficking over the top could well break the pipe. Sometimes we can put them shallower than that, but what we would do is encase the pipe in concrete. Maybe put concrete all around the pipe so that the trafficking of the cars under the road, constantly up and down the road, would not cause the pipe to break. So this is a fairly typical situation in a civil engineering situation, where you want to work out how much cover there is on the pipe, because otherwise, if there's not enough cover, you'll have to make these manholes deeper, design these manholes to go deeper, which hopefully you can do. All right, so that brings us now to F, and what is the separation distance between the existing pipeline and the exposed 225 millimeter diameter pipe at 6D? So we can see that we've got a 225 here, 225 pipe exposed, and they managed to get a level on the top of the pipe. But we need to work out the invert level on the existing pipe. Again, it's just at 60 meters, so it's the same calculation. Invert level at 60 is 67,634 minus the grade times 60. And that gives us an invert level of 67,139. Now that's an invert level. So we want to know what the top of the pipe is, so we've got to add 375. So the top of the pipe then becomes 67.514. That's the top of this existing pipe. Now, if you think about it with the exposed pipe, really, you can only get the top of that. So the top of the exposed pipe is 67,904. And so the invert level would be down 225, which is 67,679. And there appears to be a small error in the model answers in that regard. 67,904 minus 225 is not 67.563. So it's 67,679. So what's the separation between the two pipes? 67,679 minus 67,514 is 0.255, which is pretty reasonable. Again, we want to look, we don't want pipes clashing, we want a good separation between the pipes as well. So sometimes we might have to put a concrete collar or something in there just to keep everything separate and make sure one doesn't impact on the other. So, there you go. We've worked through the model answers and questions there. We've highlighted a small error in the model answers, but generally everything's pretty good. And it's taken about 26 minutes for that there. I don't quite know. Just looking at it here, I'm just going to move my calculator. That's 5, 7, 8, 10, 12 marks. 12 marks. Yeah, around about 2 minutes 24. Okay, yeah, it's probably round about how long it would take in an exam. So, or you could probably do it a little bit quicker than what I've worked through and explained it all. So, yeah, so there you go. There's that question all sorted. Hopefully, those of you that are sitting exam tomorrow, good luck. I hope this has helped. Cheers. See you.